Let's explore finding center of mass of an object. And let me get in the right spot here. I'm going to take an object, just a piece of cardboard, and we're going to find the center of mass of it. Now, this is probably too easy because it's probably not too hard. This mass is pretty much uniformly distributed. That means the same amount of mass is over in this corner as in this corner and so forth. So the mass is pretty evenly distributed. So in essence, the center mass is going to be somewhere in the middle. And if I get my finger right under the center mass, that's the balance point, or the point where all mass seems to be concentrated, or all weight will be concentrated. Oh, I got the fan on, so let me turn the fan off. This isn't going to work with the fan on. The fan is going to be pushing on the cardboard and in essence creating another torque around that axis. So got to wait for the fan to stop. But while the fan stops, I'm going to do something a different shape because this is too, I guess, simple. And it doesn't matter what shape I do, but I'm just going to cut up something that's not a rectangle. And it doesn't, again, really matter what shape I'm going to do here. So I'm just cutting. All right, well, that's our new shape, whatever this is, okay? So now trying to guess where the center of mass is going to be is a little bit harder. But I've got a neat little technique to try to figure out where that center of mass is, knowing that center of mass and center of gravity are the same thing, and gravity is a force, and the center of mass and center of gravity represent the point where all mass is concentrated, therefore the point where all weight is concentrated. So I'm going to use what's called a plumb line. I just tied a nut on the bottom of a string. So that string will hang vertically as I just suspend it like this. And then what I'm going to do is I'm going to poke 3 holes. It doesn't matter where I poke the holes, but I'm going to poke them out on the edge, and you'll see why. So I'm going to poke a hole here. I'm going to poke another hole over in this part here, and maybe I'll poke one more up here. And I want 3 because what I'm going to do is try to use each of these points as an axis of rotation. And then we're going to determine how much mass is on one side of the object versus the other. So let me get a few things. I got a pen. I probably should have brought up one more thing. But let's see if I've got something in my bag of tricks here. Maybe a pencil. All right, I need to make sure that hole is big enough that that object can rotate freely around this axis of rotation. All right, so now what I'm going to do is I'm going to stick the pencil through here, and the object is just going to hang. All right, and then I'm going to stick the pencil over in one of the other holes. It's going to rotate and eventually come to a stop. And then I'm going to do it again for the last hole, and again it's going to stop. Well, why did I do this? Well, what's going to happen here is as it stopped, that means all the torque acting about the axis of rotation to cause rotation in the clockwise direction, whichever way we're looking at here, versus the counterclockwise direction, are going to add up to 0, and angular acceleration will be 0, and angular velocity is 0 and constant. All right, and it's not rotating. Well, now I just want to figure out how much mass is over here and how much mass is over here. Well, what I'm going to do is just drop my plumb line over this pencil, over this axis of rotation. I'm going to try to do this. I'm doing multiple things at once here. All right, let's do that. Try not to interfere with the rotation of the cardboard. All right, so now I've got that hanging from the pencil roughly, and I've got this plumb line going down, which means it's dividing this object in half. So the equal amount of weight is on this side as this side. The amount of torque that this weight is generating in this direction is going to be the same amount of torque as this weight trying to rotate. Boy, my camera's on a different side than I'm expecting. Rotate in this direction. All right. So I'm just going to let that settle. I'm going to let that settle. And I'm going to put a mark where that halfway part is, as best I can, doing everything here at once. All right. All right, now I'm going to take my pencil out. I'm going to put the pencil in, which one do it? This one. I'm going to put the pencil in this one here. And I'm going to do the same thing. I'm going to let that come settle down. And half the weight is going to be on one side of this plumb line, and half the weight is going to be on the other side of this plumb line. Okay? You can see how those 2 points are now going to overlap. If I can hold that in the right spot, I can stop the pump line from swinging. It's just sort of hanging there. Okay. Where's the nut? There's the nut right there. It's just hanging down. And now what I'm going to do is the same thing. I'm going to try to put a mark right where that plumb line is dividing the the object in half. And now I've got one more point to do. Let that rotate, settle in, and drop the plumb line down. And the same amount of mass is going to be on one side of that object as on the other side. And now you can see how those 3 points are, as clumsily as I'm doing this, are starting to intersect. That intersection ends up being the center of mass. So now I draw this out, the 3 lines formed that. So I hung it from this point, and that formed one of these lines. This one right here, it should have been. All right. Then I hung it from this point, and that formed this line, equal amount of mass on this side as on this side. And then I hung it from the other point, and that created this line by hanging that, this line, equal amount of mass on this side as on this side. And so now I can test, and I should have the center mass at that point, where if I put my finger on that point, the object will balance. All right. So an easy way to use gravity, the force of gravity, to determine how much mass is on each side of a point, and then use 3 different locations, and then ultimately those 3 halves will intersect at a point that represents the center mass. So this intersection, this point right here, would be the center of mass, also known as center of gravity. Okay, so just a sort of fun way to try to find the center of mass of an object that is not easily to determine based upon measurements. Okay, I hope that helps.